Hi, I'm Cheryl Leach. In this problem, we're asked to sketch by hand the equation of 2 cosine of pi x divided by 3. And after we're done, we'll go ahead and use a graphing utility to verify our answer. All right, so the first thing I notice about my equation is that it's a cosine function. And I have a general idea about what a cosine looks like. It's a wave, right? And typically the cycle starts at the maximum, goes to an intercept, minimum, intercept, and maximum. However, I also know that you can take this basic shape and do all kinds of things to it. You can stretch it vertically, stretch or shrink it horizontally, shift it from horizontally from one side to the other, or shift it up and down. A variety of things you can do to change it. So what I'm interested in is how is this particular equation different than my basic cosine curve? All right, so we're going to start talking about amplitude, that either vertical stretching or shrinking. Now, how can I tell what the amplitude is? Well, in a general cosine curve, amplitude is determined by that value A, which in this case is a 2. So the amplitude is the absolute value of that A term, which in this case is the absolute value of 2, or 2. Now, another piece of information that you can get from that leading coefficient is whether or not my graph is reflected. In this particular case, this is a positive 2, so it's not reflected. If it had been negative 2, the negative would have flipped the entire graph. Okay, so that's the amplitude. Let's look at the period next. Okay? The period is what's going to control how much we stretch or shrink my graph horizontally. Okay? In a basic cosine curve, that's controlled by the constant that's multiplied by the x. So in my problem, that's going to be the pi divided by 3. Now, I know that typically a cosine has a period of 2 pi. So if I take 2 pi and divide it by the b term, I will get the period for this curve. So we're going to have 2 pi divided by pi over 3. And you're going to need to invert and multiply that pi over 3, and the result is 6. So instead of getting an entire cycle in between 0 and 2 pi, I'm going to get it between 0 and 6. All right, next is spacing. I mentioned earlier that when we look at a cosine curve, we're looking for a maximum, an intercept, a minimum, an intercept, and a maximum. Those are 5 key points. And I'd like to know the spacing of those 5 key points. Well, if I think about the space between 5 numbers, I'm going to have 1, 2, 3, 4 spaces. So to determine the spacing, I'm going to take my period and divide it by 4. I've already calculated the period. It's 6. And so 6 divided by 4 is 3/2. So every unit and a half, I'm going to get another one of those key points, a minimum, a maximum, or an intercept. Okay, well now I know how to space those key points, but I'd like to know what the first key point is. So is there a shift in my graph? Well, the shift is going to be determined by the expression that's inside those parentheses. So in this case, I'm talking about pi times x divided by 3. So I'm going to go ahead and look at pi times x divided by 3. Now on a typical cosine curve, the first key point happens at 0. So I'm going to set that expression equal to 0 and solve for x. When I do that, I find out that x equals 0. Well, that's where I normally start on a cosine curve. So for this particular cosine graph, I'm not shifting at all. It's staying right where it usually does. Okay, the last thing I want to consider is a vertical shift. Am I going to take the entire function and shift it either up or down? That's determined by this value d. Now, if you notice, in my equation, there's no d value written. Think of it as being plus 0. So the vertical shift is 0, and I'm not going to shift this thing up or down at all. Okay, so now I'm ready to put all of this information onto a graph. So what do I have? Well, I know that I have an amplitude of 2, so it's going to go as high as 2 and as low as -2 because there's no vertical shift. I also know that I'll be able to fit the entire graph from 0 to 6 because, again, my first key point is at 0. So from 0 to 6, I'll be able to fit my entire graph. And I know that the spacing between my key points is at 3/2. So let's try to put this all together. My first key point is at 0. And because this is a cosine curve that's not reflected, that will be a maximum. So I'm going to have my maximum point at 2. To get to my next key point, I need to move 1.5 units. So my next key point is going to be right there at 3/2. And after I hit my maximum, the next thing that should happen is I should have an intercept. The next key point is going to happen another 1.5 units later. So that's going to put me right at 3. I've got a maximum and intercept. The next key point should be the minimum. And I know the minimum is -2. So that point's on my graph. My next key point, another 1.5 units later. So that's going to be at 9/2. Maximum, intercept, minimum. It's time for another intercept. And finally, move 1 more 1.5 units. That takes me to 6. And if I follow the pattern, that should lead to a maximum value of 2. I know what the shape looks like. I have all these key points down, so let's connect the dots. And remember, that's just one cycle. This graph continues forever in both directions, just repeating this shape over and over again. All right, I've done it by hand. Let's go ahead and pull out our calculators and see if I've got the right answer. To do this, we're simply going to enter y equals 2 cosine of pi times x divided by 3 into my calculator. Now, one thing to be careful of, make sure your calculator is in radian mode. When I hit graph, I'll get a curve. Now, sometimes you don't have a good window. There's an option where you can change the window so you can zoom so that it's a trig setup. And if you do that, you'll get a nice picture of your graph. I hope that was helpful. Thanks.